So the next type of service is the process scheduling. So we had done process management. So the next one is process scheduling. So we will see how the processes are scheduled here. It deals with sharing the CPU among various tasks or processes. So the CPU is shared among various processes. So henceforth, we make use of a scheduler which handles each one of them. So scheduler is nothing but an algorithm implementation. It is a program which performs efficient way of handling the task to provide a deterministic behavior. As the CPU is shared among several processes, it has to be handled. Otherwise, there are chances that uh, maybe one process may get complete CPU time and other process may be completely ignored. So to balance each of them based on the priorities, we make use of process scheduling. So this, whatever I'm talking, is with respect to CPU. As the processes are shared by CPU, it has to be handled carefully. Now, process synchronization. Now I'm talking about the resource sharing, means deals with the synchronizing of concurrent access of a resource. Means there are several processes or tasks and all of them, they will be accessing a shared resource. They may access it concurrently. So there will be some issues. There may be some kind of deadlocks. Uh, the system may get hanged. So to balance all of them, we have to go with process synchronization. Process scheduling, it is with respect to the CPU. Process synchronization, it is usually with respect to the resources shared by several processes and they have to be synchronized. So now let's go to the next slide. Error or exception handling. So this we have seen in the initial modules. The first and second module we have come across exceptions or errors. So now exceptions are something like an interrupts only. So let's see, it deals with registering and handling the errors occurred raised during the execution of tasks. So whenever it is executing anything, there could be some abnormalities and that we call it as an exception that has to be handled. So what could be the possible exception? Something like insufficient memory, and there is no sufficient memory to put a process. Timeouts, there is somewhere the system is getting stuck and it is not able to come out. Deadlock, multiple processes trying to access a shared resource. Deadline missing, there is no, it is never ending, the process going on maybe in the infinite loop. Bus error, maybe the processes are not getting a bus. Divide by zero, in the program you have given an instruction to divide by zero, which is infinity, it cannot be handled, so it's an exception. Unknown instruction execution means you're typing a wrong instruction, so it cannot be detected by the system. So that type of situation, it will lead to unknown instruction exception. So all these are the different examples of exceptions and it has to be handled. Now, one thing we have to understand here, errors or exceptions can happen at the kernel level services or at task level. Kernel level services means at the operating system level, means errors or exception can happen at the operating system level internally. Also, there could be an exception, or at the task level, means the user applications. Now, deadlock is an example for kernel level exception. So it is an internal exception. Usually, it may not be visible to us. Internally, there may be a deadlock. Whereas timeout is an example for the task level exception. Somewhere it will wait for 5-10 minutes and finally it will tell, for example, you're trying to connect something. It goes on trying to connect to the network. It waits for some time and it is not, still it is not able to, then it will give a timeout error. So it is a task level exception. So deadlock is a kernel level exception, means multiple processes handling the shared resources. So that kind of situation, we call it as deadlock. It happens at the kernel level. Whereas timeout is a scenario wherein it's an exception happening at the task level. The OS kernel gives the information about the error in the form of a system call. So the operating system kernel gives the information about the error in the form of APIs. And through the system calls, it gives the information. Let's go to the next type. We are done with two. We are going for the next type, that is memory management. This is also a services offered by kernel. Now, the memory management function of an RTOS kernel is slightly different compared to general purpose operating system, as the structure itself is different. In general, the memory allocation time increases depending on the size of the block of memory needs to be allocated and the state of the allocated memory block. So as the memory allocation time, as the size increases, as size of the block of the program increases, even the memory allocation time also will be increases. So always the initialized memory block consumes more time than the uninitialized one because it has to search where exactly it is. Now, since predictable timing and deterministic behavior are the primary focus for an RTOS, so RTOS, we focus more on timing. RTOS achieves this by compromising the effectiveness of memory allocation. So here we give more priority to the time rather than how well the memory is utilized. Somewhere at this point of time, somewhere that process should be dumped. Whether it is an appropriate place to dump or it is not, or it should see whether which is a best block to be allocated, all the day it won't check. It will just see at this point of time, it has to be process should be allocated some memory somewhere in the memory. It will not see the effectiveness of the memory allocation. So RTOS generally uses block-based memory allocation. So it makes use of just blocks. And so we will see that block-based memory allocation in the next slide. Let's see. Now, RTOS kernel uses blocks of fixed size of dynamic memory. Means the entire memory, it is going to divide in terms of blocks, and those blocks are of fixed size, maybe like 100 MB, 100 MB, 100 MB, something like that. And the block is allocated for a task on a need basis. So whichever wants a particular memory, whichever wants a memory, it will just allocate any one of the block available. The blocks are stored in a free buffer queue. So there is no hard and fast rule. So it is available, the blocks are available in the free buffer queue. Most of the RTOS kernels allow tasks to access any of the memory blocks without any memory protection to achieve predictable timing. So it can access any block, any process can access any block. And they just to see that it will not consume more time in allocation. So in this regard, there may be less memory protection. Now, RTOS kernels assume that the whole design is proven correct and the protection is unnecessary. Here, less prominence is given to protection. Some commercial RTOS kernels allow memory protection as optional. There are certain RTOS kernels which provides this with optional. So, and the kernel enters a fail-safe mode when, so suppose if there are any issues, it just enters into a fail-safe mode. So in this way, it provides a kind of protection. Suppose there is something illegal found, it is going to switch over to the another mode. So that is a small kind of protection provided to the memory. So now the memory management function of an RTOS kernel is different from general purpose operating system. A few RTOS kernel implement virtual memory concept for memory allocation. So virtual memory concept, this briefly I had told in the last semester. It is the physical memory. Even in the class I had discussed about this. In one class I had discussed. So virtual memory is actually the addresses cannot be accessed by the user. I mean, the user will not know what is actual physical address. So the RTOS, if it implements virtual memory concept in that, then usually it is to support secondary storage devices like HDD, hard disk drive, and flash memory. Usually when they make use of these kind of memory, this virtual memory concept is implemented by RTOS. Now in the block-based memory allocation, a block of fixed memory is always allocated to the task based on the need basis. Hence, there will not be any memory fragmentation issues. So this fragmentation also is a part of operating system. So because of this type of allocation, there will not be any kind of memory fragmentation problems. The memory allocation can be implemented as constant functions, and thereby it consumes fixed amount of time for memory allocation. So it consumes a fixed amount of time. This leaves the deterministic behavior of the RTOS kernel untouched. So because of this, uh, always the particular embedded system will behave in a specific way, means the behavior is deterministic within that specified duration of time because of this kind of flexibility provided in the memory allocation. So there will not be any delay. So in case of memory, in any memory allocation, so which enables it to work in deadlines.